Alright, hello everyone, welcome to my stream. I will be working on the series Advent of Code Problems. Yeah, let's get started. So I know 2 days have already come out. I haven't looked at any of the problems yet, so let's go through it together. Quick introductions. I'm Eric. I'm a software engineer by day, and I guess by night. And I'll be working on these problems in Rust because that's my favorite language. Feel free to follow along, share your solutions, do whatever. Let me arrange these windows a little better in my stream. How do I do this? Hello? Okay, I don't know what's going on here. How do I change this window's coordinates? OBS, why are you like this? Oh, it's because I locked it, that's why. Okay, let's do this. Let's click on this tiny window, open it so that I can see the problem. Yeah. Shrink this until it makes sense. And yeah. Cool. Alright, so first things first, let's read the problem. Day 1 trebuchet. Something is wrong with global snow production and you've been selected to take a look. The elves have given you a map. On it, they've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th. Okay? Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You ask why they can't just use a weather machine. Oh, I guess this is a reference to a previous problem. Not powerful enough. And where they're even sending you. The sky. And why your map looks mostly blank. You sure ask a lot of questions. And hang on, did you realize that the elves are already loading you onto a trebuchet? Wikipedia link. Please hold still. We need to strap you in. Oops. As they're making the final adjustments, they discover that their calibration document, your puzzle input, has been amended by a very young elf who is apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the document. The newly improved calibration document consists of lines of text. Each line originally obtained a specific calibration value that the elves now need to recover. On each line, the calibration value that can be found by combining the first digit and the last digit in that order to form a single 2-digit number. And they give an example: 1 ABC2, PQR3, 8. In this example, the calibration values of the 4 lines are 12, 38, 15, and 77. Adding these together produces 142. Consider your calibration document. What is the sum of all calibration values? Okay, pretty straightforward. One tricky thing I see here, trebuchet only has 1 digit, but that 1 digit is both the first and the last digit of that line, and so the calibration value, I guess, is 77 for that line. So pretty straightforward. Let's get started. So let's see. Can you see my console? No, you cannot. Gotta shrink this down a lot. Let's get rid of this. Bring this up here. I guess I can make this a little smaller. Okay, that's about as small as I can reasonably make my window. Well, let's see. All right, let's do this. Hope everyone can see that. So first thing we're going to do, we're going to create a new project for this day. I like to create a new cargo project every day, but yeah, different ways of doing it. 2023 D1. And so now we should have a, oh, what? Is that not how to do it? This is embarrassing. How did I do it before? Okay, I guess I just gotta make the directory and then cargo new inside it. Cargo init, is that a thing? No. Okay, we're gonna do something else. We're just gonna call it D1, and that will make everyone happy. There we go. Cargo build. Oh, sorry, my big face is getting in the way here. Whoop. There we go. All right, so good, cargo runs as we expect. Let's open up the file. This is straightforward enough. There's just one file. Let's copy and paste our solution from last year's day 1, which has the basic I/O stuff that we care about, so we don't have to do that all ourselves. Alright, so first things first, let's copy the example into a text file. Here. Where are we? Okay. And so what we're going to do is we are going to read in the file. What's going on with my Rust analyzer? Where are my annotations? We're going to read the file. Get the name of the file and then read in each line by line, which we've implemented here. already, should be pretty straightforward. And then we need to actually do a computation on the lines in here. Why isn't my Rust analyzer working? That's interesting. Oh, well, I'll figure that out some other time. I guess today we're just going to be writing it raw. So here's where we want to put the code. All right, so this is pretty straightforward in that we just want to iterate over all the lines, and then we want to iterate over the characters in the lines, I think. Yeah. So let's create a function that takes in a line. And actually, what I want to use is the ASCII. Well, actually, I don't need that. Let's do this. Let's take a function make a function that takes in a line and spits out the digits associated. And let's just call it digits. So a line takes in a str, gives us a digit. What we want to do is let mut dig 0, our first. Okay, and then for char in line.chars, I believe that's how to do it. I don't have my Rust analyzer, which is really what I rely on. There we go. Fantastic. Okay, if actually let's do this. If first dot is, okay, let's do this. If is numeric, let dig parse. What's the function for parsing Rust? Two-digit is what it is. Okay, if that's what it is. Radix is 10, of course. That's just to do so that we don't get the big thing. All right, and then if we do if first dot is none, first equals to some dig. And now we should know what it is. And actually, we got to unwrap here. We could be more clever if we wanted to. We could pattern match the two-digit as either a none or a some digit and then assign that. If we wanted to be clever, I don't really care. Okay. Good stuff. And then we want to return the first and then the last digit. So that's just first.unwrap times 10 plus last. And that's what we return. Great. There's a bit of the tricky thing of, I guess, two-digit gives us a U32, whereas this is returning an I32. Doesn't really matter to me. Okay. Then lines. Let's let mut s equals 0. We're just gonna digits line. And then s, that's all we gotta return. And it can be a U, it can be whatever we want. We don't want to call it max, let's call it V for value. I guess that's not a better name at all. And let's run it on this example input. 142, is that what we expect? Sure is. All right, so now we can get the puzzle input, copy, paste, put, Oh no, it crashed. What? Wait, where did I save this file? I saved it in source, my bad. I'm sorry. There you go, that's what I want. Try it again. And that's my number. Fantastic. Gold star. We love it. All right, now part 2. Your calculation isn't quite right. It looks like some of the digits are actually spelled out with letters. 1, 2, 3, 4, 5, 6, 7, 8, and 9 also count as valid digits. Come with this 219. Wow. That's tricky. Surprisingly tricky. Okay. Well, we can do the same kind of thing, except now we need to, I guess, start greedily matching digits. Wow. Are any of these digits like supersets of each other? I guess not. Like you would never. Oh. Like it would be a problem if there was 7 and 17, because you'd have to match 17 before 7. Otherwise, if you saw 17, you would match 7, and then you would see teen, and you wouldn't do anything with that. But that's not a problem, because we only need to match the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, let's do that. I will say this is like surprisingly tricky. I'm gonna bring up. Okay, yeah. So part 2, I think we're doing basically the same thing, except now we just have a trickier parsing function. Instead of just checking if it's numeric, what we want is to also check for if we find like a string. So first things first, let's get us a function that goes from string digits to like number digits. So I don't know. Okay, and let's call this, and it takes in a string. And it gives us a U32, because we've decided that we're just using U32s now. And let's do and let's have it return an option of U32, so that if it's not, is this not what it's called? Oh yeah, that is what it's called. So that if we fail to find a string there, we return none. And so it's nice and elegant. And actually, I think what we should do is we should just greedily match digits and like spelled out words, if that makes sense. can make this wider. Looks like I have this screen stateful. Okay, so let's start with checking if it's a number. If the first character is a number, like we did before. So if stir.chars, and this is where it would be nice if Rust like Rust has an ASCII package crate, which lets you do constant time indexing. Rust normal strings are not do not have that property because Rust normal strings are UTF-8. But I don't know how well these work with like regexes. Regex. ASCII. Okay, actually, it looks like if I convert things to bytes, I could use regex bytes. It doesn't matter. That's actually not even like that important. We just want the first character. How do I do that? This is where I miss Python. You can just index the first character. But here in Rust, you have to do this crazy thing. Dot is numeric. Actually, we learned our lesson from last time. Let's numeric dig equals to dot 2-digit 10. And now that's a option U32. Great. If numeric dig dot is sum, we can just return that. We're good. We found our digit. Great. Otherwise, we gotta look for a word. So that's going to be fun. Does Rust have a Rust string starts with, does that exist? Okay, so it does exist. Why is it if I look for Rust string starts with, the first site is not the Rust docs, it's this site, and then Stack Overflow, and then this, and then this. And this will tell me that there's a starts with function. I guess those other sites are like more helpful, more straightforward. You don't have to search like for the function, but it would be nice if the official docs were respected. Okay, anyway, let's do this. If it's going to be a lot of typing, it's going to suck. If the given pattern matches the prefix of this string slice, yeah, so we're going to do stir dot starts with 1. Return sum 1. Elif, so much typing. return sum 2. One quick thing, we're assuming that the 29 8 2 3 1 3 2 4 4 2 1 4 7 6 Okay, so they didn't give an example of, like, let's say they had, I don't know, like just 8-2 with 1 T. They didn't really like tell us what to do there. But maybe the test data is just set so that that never happens and I don't have to worry about it, hopefully. All right, let's start copy pasting. Times like this, I wish I like had some kind of AI assistant who could help me fill this out way easier. Okay, so now what we're going to do is we're just going to iterate through, we're not going to iterate through the characters because that doesn't make sense anymore. We're going to iterate through the number of characters that we have and like make string slices and call this function repeatedly. So let num chars equals to line dot. Do I have a line? Yes. Okay. For chidix in 0.num chars, let's stir slice equals to line chidix. That is the syntax, right? Yes. If let's sum dig equals to stir to digit. Why is this? And then we do the same thing we did here. And I think that's it. So digits 2, P2, P2. Let's uncomment it. All right, let's see if that works. Run it on our example. That's completely wrong. So what's the problem? V2 calls P2, P2 calls digits 2, digits 2 calls. Wait, that's not completely wrong. That's a different example. My bad. Example 2.text. What? Okay, guess we can't do P1 and P2 on the same text. 282. Whoa, we are off by 1. That's super annoying. Why is that the case? All right, let's, as much as I hate to do this, I think we have to actually print out the values. Whoops, all right. Dicks. All right, 2 9 correct, 8 3 correct, 1 3 correct, 2 4 correct, 4 2 correct, 1 4 correct, and 76. That's not correct. Why did I get 7 7? That's a stupid typo. Okay. Perfect. That's what we expect. And now to run it on the real input. See if that's correct. A first try. Let's just commit this. Day 1. We'll push it to GitHub, share it with all our friends. All right, let's see what's on day 2. We've launched high into the, wait, also I completely missed the lore here. What did I need to do? Oh, right. We're using a trebuchet, but the trebuchet was miscalibrated. Now we've solved it and we can launch into the air. High into the atmosphere, apex trajectory. Snow Island. Okay, Snow Island doesn't have snow, but we're gonna play a game in the meanwhile. Small bags, small cubes, either red, green, or blue, RGB. Each time you play the game, he will hide a secret number of cubes in each color in the bag. Okay, so there's one bag and multiple cube colors, and your goal is to figure out information about the number of cubes. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this 8 times per game. Play several games, record the game 11, followed by a separated list of subsets of cubes, and that will reveal from the bag like 5 red, 3 red, 5 green, 4 blue. In game 1, there are 3 sets of cubes revealed from the elf would like to know which games would have been possible if the bag contained only 12 cubes, 13 green cubes, and 14 blue cubes. Wait, are the cubes put back in the bag? Yes, they are. Okay. The above games 1, 2, and 5 would have been possible if the bags had been loaded without configuring. Game 3 would have been impossible since at one point the elf showed you 15 blue cubes at once. Where did he do that? No, what? Sorry, 20 red cubes at once, right. Game 4 would have been impossible with 15 blue cubes. Right. If you add up the IDs of the games, oh, okay, pretty interesting. It kind of seems like this is mostly a parsing problem. Yeah, I'm thinking like we could use regexes for this. Would be a little tricky and annoying. But yeah, let's go ahead and do that. Okay. All right. Let's copy what we did there. Paste, save. Why is this yellow? What is it unhappy about? Oh, this isn't called. I see. Let's just comment these back in for posterity. Close my examples. All right. So, what do we want? Okay, so I think the strategy here is going to be just to split the line up. We can use a colon to split the game ID and the rest of the text, and then we can use semicolons to split the individual games up, like the individual, I don't know, grabs up, and then use commas to split the number of cube, marbles, whatever. Yeah, it's pretty straightforward. I want to use the ASCII crate, I think. Is ASCII in the... Is it in the standard library now, or is it... Wait, what's the difference between these? There's ASCII... What does this do? Okay, so it's all like deprecated. I think we want this one. We want the ASCII crate. Now, how do I... Where's the link to copy this thing? Here we go. All right, so what I was saying earlier is that Rust does the correct thing by considering every single byte stream, I guess, file, whatever, by default as a set of Unicode characters. That means it will correctly handle things like emoji or Chinese characters or characters with accents. Those span multiple bytes, but they will count as a single character. The downside of that, and that's good for like internationalization and just, you know, if you're writing production code that needs to serve an international audience, it's important that you handle, you know, people's names if they have accents in them, or if they're not English speaking, or they use a different alphabet. It's important to handle those cases. But the downside is, because some characters in UTF-8 take more than a byte to represent, you cannot really know, just based on how many bytes, how many characters there are. So operations like getting the length of a string and iterating through a string, well, not really iterating, but randomly accessing a byte in the string, or a character in the string, I mean, those are not those take linear time as opposed to like constant time, which is what you might expect. In our case, we know that our input's going to be ASCII, so every character will be exactly 1 byte. So we can be more efficient with our like string splitting and whatnot by using this crate. So that's what we're going to do. as soon as I figure out how to use it. So let's go to read. So read to string. I think this is the function we want to intercept. Oh my god, okay. Okay, so I think what we want is, at this stage, we have a string, and then we want to convert it into a ASCII string. Okay, I think this is basically what we want. So use ASCII ASCII string. Okay, and then we will do ASCII string from ASCII, and I think this is valid. And we're going to unwrap that because I'm sure that our input should be ASCII strings. And now other things are going to be a little unhappy, but that is okay. We will just deal with it as we go. So now it's a vec of ASCII string. That's going to change later. Now it's a vec of ASCII string. Okay, perfect. So now, okay, cool. So does ASCII string give me, what does this implement? Does, for example, does it give me split? Perfect, it does. All right, so let's do this. So we don't need this s plus. Wait, actually we do need something to count a sign, a sum, I mean. So for line, ASCII string in lines, we could probably break this down into smaller functions. I'm not going to do that because I'm lazy right now. Game split, yeah, let's call it game split equals to line dot split how does one get an ASCII char? Oh my god, how do I I'm gonna hope that it just converts automatically. Please be happy with that. No, Unicode character, what the hell is, oh, I somehow activated my Chinese IME. Is this okay? Is there a from? Okay, we're gonna do dot into, whoops. Why not? How do I get this trait in my thing? Do I use ASCII to ASCII char? Will that do it? Will that satisfy you, Mr. Compiler? No. And also it's missing a semicolon. Trait bound is not required for char to implement into ASCII char. Oh, do I have to do to ASCII char? Yes, I do. And then I want to unwrap it because that's not very ergonomic. That's super unergonomic. That's just really, really not ergonomic. Is that the only implementation of split? I guess so. Great. All right. Let game ID Rust regex ASCII string. All right. Let's use regexes. What's the version around these days? All right, so let's let game regex equals to regex new. I guess we actually want to do this outside the loop. Oops. Game blah. Okay. Oh. Game. How do I index a double-ended iterator? Is there like a get? Nth back. I don't want to advance or like. Oh, okay. Let's just collect then. Collect. Back of I guess. Is that correct? Yes, okay. Game split 0. Okay, so that works. So let's do game regex.match. It's not called match, it's called something else. Find. Or match, or... Okay, whatever. Okay, and then what do I do with this match? Start and is empty, length, range, as bytes. As bytes is what we want. Dot as bytes dot. So as bytes will give me a Rust parse ASCII digits. Oh, this is such a pain. Parse. Okay, so what we have to do here is to stir dot from what do we gotta do? We gotta do stir from UTF-8. Stir from UTF-8 dot unwrap dot parse. All right. This is not super elegant, but you know, we do what we need to do. And we've gotten the game ID, great. Okay, let's do let object cubes equal to game split 1. That's the second half. And then then we have to split this again, right? So let's call this all. Actually, let's do that in one line. Split. Split by semicolon. Yeah. All right, now what we care about here is, I guess, each individual thing. So let's just loop through that for yeah, there we go. That's great. Let cubes split equals to pick cubes that split, comma, split it by the commas. And let's collect that into a vector of ASCII stir. I think that's what we want. Missing nothing. Yeah. Okay, and then let's put a, okay, now we want to track how many of each thing, of each color we have. So let's just make a struct, call it a grab, very straightforward. Red, green, blue. Yeah. Honestly, we don't even need to do that, but whatever. Okay, let mute grab equals to grab. Let's do our fun Rust stuff. Debug, clone, copy. This could implement copy easily. Let's do default as well. I think that's really what we want. Okay. Now, let's get some matchers. So actually, we don't need matches. We could just do this by splitting. So for cube in cube split, let trimmed cube trim it, and then we can split it again by space. Oh my god. Okay. Number color equals to trimmed cube dot split ASCII space dot collect. We want this to be a vec of ASCII chars again. ASCII stirs actually. Yep. And then we're going to match a number and a color. Very straightforward. So let number equals to number color 0 dot parse. Oh, we have to do this stupid string thing again. Dot on. Activate dot unwrap dot parse dot unwrap. I should make this into a function. Let's do that. Function parse ASCII. Yeah. Cool. I see. How do I use generics in this thing? What is a 4? I really just need this. That works for me. Okay, it's crazy. And then this gotta do. Where F? Okay. P as from start. Consider comma B as from start air debug. Okay, if you say so. What does it want me to do? B as from start. What does it want? What was the thing it wanted me to do? Use stood format debug. Okay. Does that solve my problem? Okay. Cool. That was not easy, but we got it done. Right, and then let's okay, so how do I construct a raw ASCII string? Is that even possible? There we go. Okay, so we need to add up the numbers that would have been possible, not the ones that would not have been possible. Oh, that's interesting. So then just so now we've iterated through the cubes. If grab.blue greater than r, let's do this in order, 12, or grab.green greater than, or grab.blue greater than 14, false. Yes, okay, if possible, s plus equals to game ID. Yes, perfect. Let's just ignore this for now. Ignore. Cargo run example. Cool stuff. Oh, I can't believe this. You're embarrassing me in front of the wizards. Okay. So parse ASCII, that's that line, and then P1, line 61. Here, okay. Game regex dot find game split 0 dot into okay. '46 plus stood format debug. Oh, I gotta match the other thing. Okay, I'm using find instead of captures. To use captures. Unwrap. This might work. Okay, let's try it again. There we go. Okay. Now we're in business. Puzzle input. Hey. The elf says they stopped they still because they aren't getting any water. He isn't sure where the water stops. Okay, so it seems like the way to do this is just to find the minimum number of whatever in each game is equal to the number of red, green, and blue cubes multiplied together. Games 2 and 5, and then adding up, and then you have to add up the powers equal to the. Okay, it's pretty straightforward. Let's do it. Let's take the opportunity to clean this up a little. So what we're going to do is let's split this into a function that gives us like a vector of grabs. Let's do that. So derive, debug, clone, and let's do yeah, cool. Let's do that. Let's get rid of this logic. Actually, let's put it here just to remember that we have to do that. Okay, so for line and lines, game split. Let mute grabs. Let's rely on the type. All right. Okay. Let for game in games. Game.grabs. Possible equals to true. If possible. Okay, just make sure that that gives us the same answer. Good stuff. And now we can do a part 2, which is so now we don't care if it's possible or not, we just care about the minimums. So let's do let min grabs for grab in game.grabs if grab.blue greater than min grabs.blue, min grabs.blue equals to grab.blue, and then same thing for the others. So 1, 2, green, red, and then we want the powers, so we want the multiplication of these. S plus equals to min grabs dot blue times min grabs dot green times grabs dot red. Already I'm starting to anticipate we might have to go to a larger bit width for these numbers. Let's see. So 2286, that's correct. Let's, yeah, no, maybe it's fine. Fantastic, good job, first try. Time to sleep. Right, good night everyone, see you next time.